All right, class, good afternoon or morning, whatever time you're watching this. So now we are moving on to Unit 7, Exponential Functions. This first one is graphing exponential functions. So the first type of exponential function we'll do is exponential growth. Some of you may remember this from Algebra 1, because that's where you've done it at. And for this graphing section, we're going to do something at the end of this. Kind of ties into what's going on right now, because we can use the data from the COVID-19 outbreak to kind of generate an exponential curve. It's kind of fascinating for the nerds and scientists and stuff. So here we go. So this here, exponential function, you have your parent function, f of x equals your base to the x term, where b has to be greater than 1 for this to exist. It's classified as exponential, continuous, and increasing. The domain is all real numbers from negative infinity to positive infinity, which basically means from left to right here, there's no breaks in the graph. Every x value you put in, you're going to get a y value. And our range, okay, so we have asymptotes again. So my range, so right there, okay. So that's the asymptote. That means we start from 0 and go all the way up to positive infinity. All right, and as I said, there's your asymptote, and our intercepts are at 0, 1. Okay, so our parent function and the graph that I used right here is y, change it, keep the notation correct. I used f of x equals 2 to the x power. All right, so what I did, you can again use Desmos. Hopefully you guys are getting good at that. So I use negative 2, negative 1, 0, 1, and 2. Okay, so what happens, so if I plug x into the function, you get 2 to the negative 2. I can't have negative exponents, it becomes 1 over 2 to the 2. We flip it, and we get 1/4, or 0.25. Then 2 to the negative 1 becomes 1 over 2 to the negative 1. Oh, sorry. It's positive now, we flipped it. Okay, and this becomes 1 over 2, or 0.5. Alright, and then we have 2 to the 0. Anything to the 0 is 1. It's nice and easy. 2 to the first power is 2. 2 squared is 4. Alright, and you can see on the graph you have negative 1 1/2, negative 2 1/4, and if we keep going negative, you see it gets closer and closer to 0. And then 1's at 2 and 2's at 4. So we can see that there's a big jump from there to there. And so the next one will be a bigger jump because that'll be 8. So it'll be all the way up here. So the jumps get bigger, which is what exponential functions do. They grow or get smaller really, really fast. I usually, in class, when I'm teaching this to you guys, I tend to compare it to the zombie apocalypse, because you always start at, right here at patient 0, and before you know it, 2 patients, and it gets, I'm sorry. I mean, you got 1 person, and the next thing you know, you got 4, and then, if you watch World War Z, then there's all zombies, pretty much. All right, it's kind of, minus the zombie part is, we're hoping by quote unquote flattening the curve is trying to stop this exponential growth. All right, so let's hammer out our first example. Okay, so we're given the function f of x equals 3 to the x. All right, and then you're going to state the domain range. So I usually just, like I said, you can put it in Desmos. You don't have to do the handwork, but I'll just create a table of values. Don't need a ton of points. I'll do negative 2, negative 1, 0, 1, and 2. All right. So 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. So you get 1, 3, and 9. 3 to the negative 1 is really 1 over 3. Or 1/3, or 0.333. 3 to the negative 2 is 1 over 3 squared, which is 1 over 9. Okay, so I don't have any h or k's yet, so my horizontal asymptote will be here at 0, because k, like in rational functions, is our horizontal asymptote, and k would be 0 in this situation. All right. Oops. So plotting the points, 0, 1, 1, 3, 2, 9. And then -1's the third. You just kind of draw them closer. Draw your graph. It's like half a rational function. There you go. So there's your graph. Now our domain is the same. So left to right, negative infinity to positive infinity. There's no breaks in the graph. Our range, all right, this is the same for all exponential functions. And then our range, we go from 0, and the graph goes up to positive infinity. And there you go. Probably one of the easiest things we've graphed so far. Now we're going to add the h and k's in here. So h, as always, is our horizontal shift. All right, and again, remember it's always opposite sign. All right, so positive h, you go left. Negative h, you go right. Oh, jeez. Right. K is our vertical shift. This is always the same sign. All right, these basically affect your asymptotes. So positive k is up, negative k is down. All right, if a is negative, it is a reflection over the x-axis. A is greater than 1. We stretch vertically. If A is in between 0 and 1, we compress vertically. Okay. This is example 2. This is our K. So our horizontal asymptote is f of x equals 1. That means our graph is shifted up 1 unit. So I'll sketch that in there real fast. X, f of x, 0, 1, 2, 3. So 2 to the 0 plus 1 is equal to 1 plus 1, 2. 2 to the 1 plus 1 is 2 plus 1 is 3. 2 to the 2 plus 1 is 5. 2 cubed plus 1 is 8 plus 1, which is 9. Okay, plot these points. Darn. So my y-intercept's at 2. Come up 3. 2 goes to 5, and 3 goes to 9. Sketch as it gets close to the asymptote, and then we go all the way up. Boom. And then your domain and range. Domain's the same, as I said in the previous problem, negative infinity, positive infinity. Our range, and then again, okay, this is interval notation. My range is my horizontal asymptote, which is 1, and it goes up to positive infinity. Alright, so now we got one that's got a little bit of a twist and pop in here. So we have -1/2 times 5 to the x minus 2 power. Alright, and then this will be plus 0 on the outside. So h is 2, k is 0. And see that this is negative right here, so we're going to reflect. So instead of it going up like that, the graph is going to go down. Okay, table x, f of x, 0, 1, 2, and 3. Plug into the calculator, plug into Desmos, we get -0.02, -0.10, -0.5, and -2.5. So my horizontal asymptote is 0. I guess I'll write it. Okay. So my 0 and negative point, so it's very close. And then 1, still closer, get about halfway. And then 3 is -2.5. So sketch my graph. Oh, I whiffed hard on that one. Sketch my graph. Okay. Domain, no change. Range, so we start at 0 and then we go down to -infinity. Graph's going down now. Okay, so those are all exponential growth. Exponential decay is the same thing except for we decrease left to right. Alright, so its number starts very high and it gets really low. Okay, kind of like, and again, zombie apocalypse, the human population is very high, but by the end of a movie or a show or whatever happens, it's usually very, very low. Okay, so domain's the same, range is the same, asymptotes, intercepts, that's all the same. The only difference is graph goes down from left to right. Okay. So I have h is 0, k is 0, so my horizontal asymptote is 0. Okay, and these numbers in front here will usually be a fraction. All right, let's think I could talk about up here. Yeah, so this b is in between 0 and 1, so it's always going to be a fraction, which causes the decay. And then we just plug numbers in. -2, -1, 0, 1, and 2. I'll get 9, 3, 1, 1/3, 1/9. So it's the flip of 3 to the x. Okay, if you look at the table of the example 1 and then you look at this one, the tables are just flip-flopped. -2, +9, -1, 3, 0, 1, 1/3, 1/9, and then it continues on until we get close to 0, but never actually touches it. Domain, -infinity, +infinity, no changes, good habits. We go from 0 to +infinity. Example 2. Okay, h is -2, k is -3, horizontal asymptote is at -3. There it is. So I'll do -3, -2, -1. I'm picking numbers more on the left side because we're decreasing. 0, 1, 2. All right, so -3 is 5. -2 is -1. -1 is -2.5. -2.9er. And then we get smaller and smaller and smaller. So I'm only worried about those couple of points. Okay. -3 is up at 5. This one's dropping pretty fast. Okay. So it's a steeper one. And that comes from that 2 all the way out front. Domain, as you guessed it, no change. 3 points. Horizontal asymptote is at -3 and the graph goes up. There we go. Oh, word problem, great one. Okay, these are actually good for pharmaceutical world. Alright, you take medication, like when you go in to get antibiotics, something like that, you always take 2 at first, because that really jumpstarts your system. And what your body does after time, just kind of like slowly gets it out of there. So you got to keep taking the pill to keep it in your system, just like birth control. If you stop taking it, you run a risk getting pregnant. But that's why you got to stay on it, because it keeps that minimum dosage in the body. Alright, so a cup of green tea contains 35 milligrams of caffeine. Average teen can eliminate 12.5% of the caffeine from their system per hour. Estimate the amount of caffeine in a teenager's body after 3 hours. So above we have our formulas for growth or decay. Alright, so since we start at a certain amount, it decreases. So we're going to use a decay for this problem. Alright, so I'll say A sub t is equal to A, not sub t, A of t, 1 minus r to the t power. Alright, where A is our initial amount, r is the rate, okay, usually percentage, all right, how much we're dropping or increasing, and then t is time. All right, so A of t, so my initial amount, so A equals 35 milligrams. My rate is 12.5% or 0.125. Remember to convert, divide by 100, or just slide 2 places to the left. And then my time is 3 hours. So what you gotta do is plug in the formula and solve it. So that's 35, 1 minus 0.125 to the 3rd power. You can just plug this all in the calculator real fast. Okay, or you can put so you can make this in the Desmos down here. So if you want to use the table, all right, so you'll say, let me think. So f, I'll put in x, y terms. F of x is 35. Sorry, doing it on the fly. 1 minus 0.125 to the t power. Oh, sorry, talking x. So that should be x. You plug that into the Desmos, it'll give you the table. and then you just play with T to figure out what you can get. All right, or you can plug it in your calculator, and the final answer is going to be 23.4 milligrams of caffeine remaining. Green tea is nasty, by the way. Sorry for those of you that like it. Okay. All right, that's it. Not a bad lesson. Okay, it's graphing. Graphing shouldn't be too hard. Again, use Desmos to help. I'll probably make another quick little tutorial and I'll post that for you. Email me with questions. All right, guys. See you later.